Okay, so this is a problem about Kp and Kc. The problem is actually pretty straightforward here. They give you a pressure-based equilibrium constant, and they calculate concentration-based equilibrium constant, and they give you a temperature, and they show the reaction. What's important in here is what we call the, I don't know what happened. What is called the delta N gas. Okay? So if you look at the product minus reactant, how many number of gas? I'm just counting the gas, and luckily this is everything is a gas here. So delta Ng is 1 minus 3, which is minus 2. Okay? From left to right, there is a number of moles of gas is changing, decreased by 2 moles. And then that's my delta Ng, which is a notation shown up here. And the equation that you will use is the notation shown up here. Okay? And that notation, I'm going to explain it to you one more time to recap what you learned in the lecture. And this, I'm going to start with something as everyone knows, should know about this. Okay? Okay, so. Everyone knows this equation, right? PV equal nRT. And then I'm going to change this equation. Our pressure is N over V RT. Right? And then what do even I will put a little bracket to emphasize. What's this? This is a mole per liter, right? And this is if I use an ATM, my pressure, this R should be 0.082 ATM liter per mole Kelvin. And I guess a T has to be in a unit of absolute temperature. Okay. So what I'm saying here is I don't like to write this one in this way, but P is a concentration times RT. Right? So concentration pressures are related, and the offset factor is an RT. So that's why you are seeing this RT shown up here, and with a delta N followed by this. It's essentially any pressure ratio, any concentration ratio, product and the reactant, the ratio of RT shown up in here. Right? So it's the same drill that you guys see. And really only the bothering part that you have to know is you must use the R, not the one that, I think that some of you might remember, 8.314 joule per mole Kelvin. This is not the time for you to use this one, because your choice is not to make the joule. Your choice is pressure is an ATM, liter per mole is your concentration, so liter is my volume unit. So that's the number that you have to use. Okay, so I think this is a background, and so therefore, let's see this Kc. Because they ask you what's my Kc value. Kc is Kp times RT. In this case now minus delta Ng. Okay? I think I just flipped that equation because the Kp was given. And my delta Ng is minus 2, so therefore this is actually, in this case particular, is an RT to the square. And then, okay, let me just plug in the number, 6.3 and to the minus 3. 0.082, and then 225 plus 273, that will give you 498 Kelvin, so 498, just plug it in, and you will see 11. Like the exact number is 10.5, but I only have 2 significant figures, so I'm going to say 11 is mine. Okay. So the Kc is 11.